Right, we've talked about how important it is to have strong data, a good random sample, and all that kind of stuff, and how to look and see if it has a good correlation. So, one thing we're going to do is find regression equations for our data. So, I've got some data here for you. This is 18-year-old guys, a random sample of 18-year-old guys, and their weight compared with their height. And we want to look and see if there's a good strong correlation in this data and see if we can fit a regression equation to that data. So if you put in your calculator, I put mine in lists 4 and 5. You can put them in whichever list you want, but just put all this data into your calculator. I assume you know how to do that. You go to Stat and go to Edit and put it in your list. And then what we want to do is plot it. So we'll go to Stat Plot, and we're going to turn on the first one and make sure your y equals is all cleared out so that you don't have extra graphs going on in there. And we're going to use a scatter plot, and whatever list you put it in, put the weight list as your x list and your height list as your y list. And then our window, we're going to have to obviously adjust so that our data will fit in it. Well, our x is our weight, so I chose to put mine between 125 and 225 so that I had a little flex on either end. And then I just scaled it at 10 because that way I don't have a whole load of little dots on my x-axis. And then our y min and y max, I put between 60 and 80. Again, give me a little flex on either end. And I just scaled that at 1. So if we graph it, we get a graph that looks like this. Now that is a strong positive correlation, and it actually looks fairly straight. So we should be able to find a linear regression line to go with that. So the way we find that is we go to Stat and over to Calc. Now we talked about using the one variable statistics already, and what we're not going to use that other stuff just yet. But the rest of a lot of the rest of this stuff is different regression equations. And you see there the lin reg, that's a linear regression. There's a quadratic, that's if it looks like a parabola, a cubic, quartic to the 4th power polynomial, another linear regression line with the equation being a little bit different, a natural log regression line, an exponential regression, a power function regression, a logistic, which is logarithms and things like that we haven't talked about. What a logistic is, a sinusoidal regulation, or regression, sorry. But we're going to look at the linear one, which is number 4, the first one up there. And what we need to do is put in the lists that we have. So for my x list, I have list 4, and my y list, I have list 5, and then we're just going to put all this in and calculate it, and we get this equation here. So on your calculator, it looks like that. So what this is y equals 0.159x plus 45.363, so that we can see our equation. So then if we go to the y equals and put that in, and then graph it, you see that we have a line where all the data points are very close to that. That's a very strong correlation for this linear regression line. And what that means is we can look at different points along here, and we can pick a weight and come up here and find the point on the line that goes with that weight, find its y value, and we can estimate what someone's height is going to be. You've probably seen when you have gone in for checkups, the growth charts and things like that. That's a regression line from data given the population of the United States is where we get our growth charts. Obviously, those are not linear because it takes into account all ages, and your growth is not linear throughout your life. But in this little section here for 18-year-old boys, we have this little area that we can look at and estimate just this little portion to be linear, and it has a very strong positive correlation. The heavier you are, you're probably taller. So to find the regression lines, you put in your data and then go to the stat, choose which regression is the best. If you want a linear regression, which is mostly what we're going to deal with, you use that number 4 lin reg 1, it says ax plus b, and find out what your regression line is, and you can put it in at your y equals and see how they correlate together so that you can use it to find what other data points might be using this. So because this is such a strong correlation, we can make good decisions based in this little area of data based on our regression line.